All right, guys, we're going to maximize the volume of a box that can be created by a 20-inch by 25-inch piece of rectangular cardboard. All right, so in order to do that, I'm going to draw a picture first of all. I'm going to say, hey, look, I have got a rectangle. Beautiful rectangle right there. And we're going to say that it is 20 inches by 25 inches. And well, if I've got this piece of paper right here, maybe this is that 20 by 25 inch, I can make a box out of this. So if I start folding it up and I start folding it up and then I fold it up some more and I fold it up some more, I can make a box just like this, but the problem is I've got all these little corners here that are kind of overlapping when I fold that out. I wonder if I was to take this and I just cut those little boxes out so everything will be folded up correctly. Let me get out some scissors real quick. Maybe do this once or twice. So let's go ahead and, oh my God, look at that. I did it. Check it out. I cut it all out. And what you're going to notice is if I cut out that corner right there, it folds up into a nice little piece on that. But when I've cut it out, oh my God, another one appeared. I cut it out and then look what happens. I get a nice box like that. Well, what did I cut out of those corners? Guess what? I cut out squares. Check it out, squares. I cut out squares, which means the amount that I cut out was the same on the length and the width. That is crazy. So I had to cut out squares each time to make this box fold up into this piece. Now you're going to notice this. These were all exactly the same. These were all exactly the same pieces of paper. But if you'll notice, the boxes came out a little bit different. One's a little shorter and taller, one's longer and shorter, and one is almost flat. So let's do some math with it. All right, so now we're on the right platform for this math right here. We're on Desmo, so we can make some calculations. So the first thing I want to review from that last video was, hey, look, we're cutting out squares, which means the length and the width are exactly the same that we're cutting out. And we're doing that in each corner. So what I'm going to do is I'm going to represent that. I'm going to say, hey, look, we're cutting out a square in each one of these corners. But we don't know what length to cut out to maximize volume. It could be big. It could be small. So what I'm going to do is I'm just going to say, hey, let's call it X. So I'm going to say X, 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 and X. We're going to do that every single time. But notice what happens. When we cut out that X, we're only left with this piece. Essentially, check it out. We've cut out this square, we've cut out this square, and we're only left with that part. Okay? And so if I think about it, well, this whole side was 25, so this must be 25 minus, well, that X and that X, that's 2 X's. Okay? And then the next one was, well, 20, which is right there, minus that X and that X. So that's really 20 minus 2X. Okay, well, how tall is it? Well, check it out. We cut it out, and it became as tall as the amount that we cut out. That was X. So we know the height is going to be X. So I think I spelled that wrong maybe. So that is going to be X, okay? So when we think about the volume of a box, it's nice and easy. Okay? The volume is length times width times height. And what do we have? We've got the length, 25 minus 2x. The width, 20 minus 2x. And the height now, which is, all right, so we've gone a whole extra step. I took that flat piece of cardboard with the X's cut out on the sides because they were squares getting cut out. And what I did was I folded it up, and that's where that picture is right now. Let's make the function for the volume of this box. Easy, easy, easy. Remember, volume of a box is just simply length times width times height. So length times width times height. And so I'm going to write it just like that. V of X, volume of the box, equals to 25 minus 2X, 20 minus 2X, and the height, which was what we cut out, which was the X. I'm going to put X right there. Let's go over to our cell and let's start typing this stuff in. 25 minus 2X We're going to put in the next one, 20 minus 2x, and then let's put in x to finalize this thing. Now, one of the things, we got to get a graphing window in there. And what I want to do is I want to think back to the shortest dimension in there, which was 20 inches. We had to cut out squares. We had to cut out squares. Well, that means we cut out the same here and the same here. If it's 20 across, I can only go into the middle of it, which is the 10 line. So when I set this window, I'm going to go to my x max as half of the shortest side, which in our case is just simply 10. Okay. And then I don't need negatives. We're not cutting that out. So we've got that. All I got to do is my y maximum. You can see it going up and then it's coming back down. So let's go ahead and increase those until we see them. Maybe 200. Nope. Let's try 500. Nope. Let's try 1,000. And let's see what happens. There we go. Once we're there, Desmos is nice because we can go ahead and rearrange some stuff. Now, in that piece, we said 10 was the most we could cut out, half of the shortest side, okay? And because of that, there's our 10, that's our limit. Don't look past that. No, it's do not need, okay? So I'm gonna write that, do not need, okay? So when I find this maximum, I'm going to be looking for a local maximum, what we call a relative maximum. That's where we're going for. Check out in the top of this graph right here. It gives us that information. It is 3.681, 3.681. And that's going to be the maximum height, or x, which is 3.681. And then it gives us this maximum volume of 820.528 inches cubed. So the max volume is 820.53 inches cubed. Now, the goal is, well, let's find all the dimensions. We know the height. That's this one. And by the way, I did spell that correctly, like I said earlier in the video. 3.681. Let's go ahead and find the other dimensions. We need the length and we need the width. Now, when we do that, nice and easy, all we do is we come back to our original equation and we break it into the three pieces. So I'm going to type in 25 minus 2 times 3.68. And then I'm going to type in 20 minus 2 times 3.68. Check it out. Our length is going to be 17.64. Length is going to be 17.64 inches. And our width is going to be 12.64 inches. That's how we maximize volume of a box given a flat piece of cardboard. And that's how we maximize it with those correct dimensions. What a great time. I hope this helps you all out.